Hello and welcome to Algebra 2. Today is Friday, September 18th. We're going to write this at the top of our page, and our topic for today is Remainder Theorem Part 2. The main focus of today's lesson is a use of the remainder theorem. There's a way that we can use the remainder theorem to identify an unknown variable. So I think the best way to do this one is just to dive into the first example. So make sure you pause here and that you write out the whole original problem. Okay, a polynomial function is defined by p of x. I see that I have an a and an x here. Okay, that'll come into play later. When p of x is divided by x plus 1, the remainder is 2. And then it says, is x plus 1 a factor? Find the value of a. So let's look at part A first. Is x plus 1 a factor? Well, it's only a factor when the remainder is 0. Because if the remainder is 0, it means it divided in perfectly, nothing left over, so it would be a factor. Anything but 0, it is not a factor. Let's write that out. When the remainder equals 0, it is a factor, it being the factor that you're trying to divide by. And when the remainder is anything but 0, so we're going to say when the remainder does not equal 0, positive, negative, decimal, fraction, literally anything but 0, it is not a factor. So we're going to utilize these to craft our explanation for part A. So we're going to write x plus 1 is not a factor, b slash c, because x plus 1 is not a factor because when we divide p of x by x plus 1, the remainder is 2. We're going to say, in order for it to be a factor, the remainder would have to be 0. Because when the remainder is 0, it means it divided in perfectly. There's nothing left over. It is a factor. But our remainder here was 2. Okay. I'm going to block out some space right here. And this is where we're going to do part B. Okay. So it says find the value of A. So here's some A's. Here's some A's. All right. A couple things to notice here. The first is if we're dividing by x plus 1, we're going to solve this. We're going to set it equal to 0. That means we're plugging in -1. Remember the remainder theorem? We plug in a number, it outputs the remainder. So this is saying that p of -1, see, we replaced the x in p of x with -1. That means we're plugging in -1. P of -1 equals 2. It must equal 2 because 2 is the remainder, and it will always equal the remainder, whatever that is. So we know that when we plug in -1 to this function, all of it is going to equal 2. So let's do that. Let me zoom out. Okay. So I'm going to plug in -1. We're going to plug it into every single x because it is p of x. We leave the a alone by itself. So I've got -1 cubed plus a times -1 squared plus 2a times -1, and the 6 doesn't have an x, so we leave it. So let me do some color coding. In green, p of -1, all of this is p of -1 because we plugged it in. And all of that equals 2 because that's what our remainder is. And our remainder theorem states that when we plug in this number, we're going to output the remainder. Great. Now that it's all set up, all we have to do is crunch our numbers and solve for a. So I'm going to do -1 cubed right here. -1 times -1 is -1. -1 times -1 is 1 times -1. So -1 cubed is still -1. So I've got -1 plus -1 squared is +1. That's times -1. So now I have minus 2a plus 6 equals 2. Okay, I got -1. A times 1 is just a minus 2a plus 6 equals 2. I've got -1a minus 2a is -a plus 6 equals 2. Let's combine the -1 and the 6. We're going to get +5. -a plus 5 equals 2. Subtract the 5. -a equals -3. I can multiply both sides by -1. And we get that a equals 3. Great. That's it. We had our explanation for part B, and for part A, and then we found the value of A like part B wanted. Okay, we're going to do one more example like this. Alrighty. Call this example 2. You should pause here and rewrite the original problem. Part A. Okay, wait, let's read the problem. A polynomial function is defined by f of x, da 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 da. When f of x is divided by x plus 2, the remainder is 3. Our answer for part A is no. And the explanation is the same explanation up here. I'm not going to write it a second time right now, but it's the same idea. It is not a factor because the remainder is not 0. Find the value of A. All right, let's do our part B. So I have x plus 2. I'm going to set it equal to 0 to figure out what I need to plug in. Take away 2, and now I've got x is -2. Cool. So I know that p of -2 equals 3. I know it equals 3 because they told us that's what the remainder is, and I got -2 from this original factor. So this is what you plug in, and this is our remainder. Okay, let's go ahead and plug in -2. Remember, we're only going to plug it into the x's because it says f of x and not into the a's. So I've got -2 cubed plus a times -2 squared plus 2a times -2 minus 3. Let's color code p of -2. So all of this is p of -2. So we plugged in the -2 for the x. And then all of that is still going to equal 3. Great. Now that we have it set up, all we have to do is crunch our numbers. Let me do -2 cubed over here. That's -2 times -2 times -2. -2 times -2 is +4. Times -2 is -8. So this here is -8 plus a -2 squared is 4. Right here, we're looking at this unit. So it's 2a times -2 is negative 4a. Minus 3 equals 3. Okay? Negative 8, a times 4, 4a, minus 4a, minus 3 equals 3. So right off the bat, I see that these two guys actually cancel each other out. That's going to be 0a. There is no more a left, and in this case, we actually have no solution. We have no solution because all the a's canceled out entirely. So if they cancel, there's nothing to solve for. All right, that's all for today, guys. Thanks.